Number 7, we are going to solve systems of equation using the elimination method with multiplication and addition. If I would try to solve either of these equations for x or for y, I'd have some pretty nasty looking fractions, and most of the time we don't like fractions, and so we have to find a different way to solve that. One of the ways to solve it is by what they call the elimination method. We want to either eliminate the x's or eliminate the y's by finding a common multiple and then multiplying either one or both of our equations so we have opposites. So in this case, if I want to get rid of my x's, I want to think about the least common multiple of 3 and 4. The least common multiple of 3 and 4 is 12. So I want one to be positive 12 and one to be negative 12. Since these already have opposite signs, I don't have to worry about making the signs opposite. I just need to make the numbers 12. So I'm going to take the top times 3 and the bottom times 4. 3 times negative 4 would give me negative 12x. 4 times 3x gives me positive 12x. When I do that, I have to multiply it by the entire equation. So I'm going to multiply the whole top equation times 3. 3 times negative 4x is negative 12x. 3 times a positive 9y is a positive 27y. 3 times 19 must be about 57. My bottom equation, I'm going to take everything times 4. 4 times 3x is 12x. 4 times negative 4y is negative 16y. 4 times a negative 17, negative 68. Now I'm going to get rid of the x's by adding those two expressions together. Negative 12 plus 12 would give me 0 x's, or get rid of the x's. 27 minus 16 would be 11y. 57 minus 68 is negative 11. And then all I have to do to solve that is just divide by my coefficient. So negative 11 divided by a positive 11 is going to give me negative 1. Now in this one, it's not quite so easy to find my other answer. I have to substitute that negative 1 in either of my two equations and then solve it for the missing variable. So in this case, I'm just going to pick the top equation. If I do the top equation, I'm going to have negative 4x plus 9 times my y value. We had y was negative 1 equals 19. So when I solve that, first thing I want to do is get rid of these parentheses here. So negative 4x, positive times the negative would be negative 9 equals 19. Solving that, I'm going to have to add my 9. So negative 4x is going to equal 28. And dividing by my negative 4, x is going to equal negative 7. So negative 7 and negative 1. Same kind of thing, if you wanted to check your answer to make sure you did it right, substitute in for the x and the y on your opposite equation. So take 3 times negative 7 minus 4 times negative 1 to see if you get an answer of negative 17. Negative 21 plus 4, sure enough, is negative 17, so it does check out that x is negative 7 and y is negative 1. So on that top equation here, if I want to get rid of the y's, because I have this as 6, we said we want to multiply that top equation times negative 2. I didn't take the 1 times negative 2, so it didn't come out right. Negative 2 times 4x was negative 8x. Negative 2 times 3 would have been minus 6y. Negative 2 times 1 should have been negative 2 instead of 1 there. The bottom equation is going to stay the same because we had that plus 6y. 7x plus 6y equals 7. So when we added those together, negative 8 plus 7 would have been negative 1x. Our y's would have canceled. Negative 2 plus 7 would have been 5 there. Dividing by negative 1, x is going to equal negative 5. Then we still have to go back and find our y. We would put the -5 in for the x value on our top equation. So 4 times the x value of -5 plus 3y equals 1. 4 times -5 is -20 plus 3y equals 1. Adding my 20, 3y would have equaled 21, and dividing by 3, y equals 7. So you'll want to fix number 8 there because the answers there should have been -5 and +7. Number 9. If I have -4x plus 7y equals 4 and 5x minus 6y equals -5. I don't know that either the x's or y's would be too much different to solve. I'd probably just use the x's because my numbers are smaller. If I want to eliminate my x's, what should I take the top equation times?
5.
5. And the bottom equation times? 4. Because my least common multiple would be 20, and I already have opposite signs, so I'm going to get -20 on top and +20 on the bottom. So multiplying my top equation times 5. -20x plus 35y is going to equal 20. Then multiplying my bottom equation times 4. 20x minus 24y equals -20. So when I add those equations together, I get
5y.
35 minus 24 would be 11y. 11y equals 0. And when you take 0 and divide it by 11, guess what? You still get 0, right? So y is going to be 0. Do you want to substitute that in the top equation or the bottom equation? Top equation. If I put it in the top equation, what am I going to have? I'm going to have -4x plus 7 times 0 equals 4. Then I got to solve that. So 7 times 0 is 0, so -4x equals 4. And then I divide. And Kenyon said, oh, yep, it's -1. So x is -1 and y is 0. The next ones basically are reading